Okay, we're going to make a rule about doing scales. How to write a scale proportion. Okay, so let's just say we're always going to do it like this. Diagram to real life. Can you write that down and box it or highlight it or something like that? Diagram to real life. Okay, so some examples could be like this, 1 to 250. So what does that mean? It means every one, whatever unit you're doing, on the diagram is actually 250 of those in real life. So which object is bigger?
Real life.
The real life is big. And what do you think I would ever use that for in real life? What's something that you would draw a small diagram because you can't fit the real thing onto a paper? Like what?
I know someone who was making a horse sculpture, like, but really small, and then using that small horse diagram type thing to build a massive one.
Right. So it's like a statue kind of thing. This gets used every day, all the time, for what kind of business? Who would use this? What kind of worker in real life would use this all the time? Engineers, architects, building design, house plans. So if you were doing a house plan, right? Or sometime maybe you could like design your bedroom on a paper. You have to measure your bed and then draw it smaller on the paper, right? So what if somebody had something like this? Every 50 on the diagram is only 1 in real life. So now the real life is small. It's really small. Because we could hardly see it, we kind of blew it up for our paper. What would be something in real life that'd be so small we'd actually want to draw it bigger for our paper? Biology cells. Right? People who are looking at science through a microscope, they're doing that, right? They're looking at something so small, and then when they're trying to draw it on a diagram, they'll enlarge it, right? Okay. Here is a house plan, a room drawn. So it says 1 to 50. So diagram to real life. Okay, what are the actual dimensions of the room? Convert measurements to meters. Okay, so the room is 6 centimeters. How big is 6 centimeters in real life? When we knew, so diagram to real. 6 on the diagram is how many in real life? We knew 1 diameter is 50 in the real. I guess I could put colons there. So again, do you notice how every single time I'm just setting up proportions and then I'm doing a cross multiply? So 300 centimeters is that width of the room. But now it also says to convert to meters. Okay, So 300 centimeters is how many meters? And what do you know? Centimeters and meters. Is there anything on that sheet I gave you on Thursday? You lost it. Is there anything with centimeters and meters on there? Well, don't show it to me. You look.
I don't know. I don't know what to study.
Do you guys know what a meter looks like with your arms?
Like a meter.
A meter stick. Okay, so I'm visualizing a meter stick. How many centimeters are in there?
Like 100,000.
100. You're thinking of
In the 100.
100. You're thinking of a kilometer with meters. Yeah.
That's like 3 meters.
Okay, so we knew that in a meter there was 100 centimeters. Was it not on that sheet?
It is.
It is. You found it.
Yep.
So 300 divided by 100, we can do that in our brains without a calculator, is 3 meters. This room is 3 meters long. Wow, I'm not really sure how they're fitting a couch into this. Okay, and we're going to do the other side. So this room is 9 centimeters on your paper. So on the diagram, I had 9 centimeters. I'm going to ask how much is that in real life? And then at the bottom, I had a scale. 1 on the diagram is 50 in real life. So I'm timesing that. We're doing this all without a calculator because we're so good at math. 450 centimeters. But then I want that in meters. So 450 centimeters is how many meters? And then we have just a copy of the same at the top. My conversion, because I found that on my conversion sheet. So we're also going to do this in our head. What is 450 divided by 100? 4.5. Okay. So we know that diagram to real life. Okay, a drawing of a cell studied in biology class. In the drawing, the diameter of the cell was 4.5 centimeters, and the cell in real life was 0.15 millimeters. What scale factor was used for this drawing? Okay, first of all, I have a problem. What is the problem when I look at those numbers? Without any words or anything, what's the problem with these two things? Not the same unit. Okay, I feel like everything we're going to do should go to millimeters would be better than going into millimeters. Okay, 4.5 centimeters, we're going to change it to millimeters. Okay, are you visualizing a centimeter? Centimeters like that, right? How many millimeters are inside that? 10. Yeah, you knew that. 1 centimeter is 10 millimeters. So therefore, 45 millimeters. Okay, now we're going to go diagram to real life. So which number was on the diagram? 45 millimeters was on the diagram, but in real life, it was that. Okay. Which one of those should I make a 1? Which one of them is smaller? This one. So that one should be a 1. Do you remember when we wrote this down over here? 50 to 1 means that the real life is something small, and the diagram, we blew it up. Okay, so that's what we're doing. We're studying a cell in biology. Okay, so can you get me this number? Do you understand what you're going to do? Times and divide. Okay, so you can do that one in your calculator. Times and divide. So you always are going to ask yourself, which one should I make a 1? So the smaller one you turn into a 1, whatever one's smaller. So does this look right? The scale is 300 to 1. So remember how small a cell will be in your body? It's blown up 300 times in the picture that you're drawing on the paper. Okay, if I ever had just a scale factor, is this telling me I'm going to enlarge or reduce something? So if I told you I'm going to make something 112% its original size, would it get bigger or smaller? It would get larger, right? 112% makes something go over 100% its original. If you used a scale factor of 0.75, would that make something larger or smaller? Smaller. And if I used a scale factor of 4/9, would that increase something or decrease something? Decrease, smaller. So basically, when you're looking at percents, as a percent, you're going to get smaller. If you go 80% of something, it makes something smaller. If you're over 100%, it makes something bigger. Does that make sense to you? As a percent. And if you're just looking at numbers, then you're asking yourself, is it bigger or smaller than 1? Because 100% as a number is 1. Okay, so like this one would be timesing something by 1.12, which is larger than 1, which is increasing something. Okay, on a plan, an actual length of 6 feet is represented by 5 inches. I have a problem. Feet, inches. Okay, that's not going to match. What do we just want to go to? Do we want to make everything feet or everything inches? Do we know which one's easier to go to? I think everything is easier in inches. Okay, so 6 feet is how many inches? Anybody know that? Because they've built something before with a tape measure. Do you know how big a foot is? That. Can you visualize how many inches are in there? 12, yep. 1 foot is 12 inches. Okay? Is that on the sheet that I gave you? You have it in front of you? Okay, so I'm going to times. So that is 72 inches. Okay, so diagram to real life. Okay, so I have a 72 and a 5. 72 and a 5. Okay, which one is on the diagram? The actual is 72 and it's represented by 5. So what am I putting on the diagram? 5 inches. And then, but in real life, that's 72 inches. Okay, I'm going to change one of these into a 1. Which one of them should I change? The 5. So I'm going to, just every time, everything we're going to end up doing, setting up a cross multiply. Times, divide. Okay, so that's my scale, which means my real life object is 14.4 times bigger. Okay, a billboard measures, so a billboard, you know how billboards are on the side of the highway? Measures 4.5 meters by 3.5 meters. And we're trying to draw this billboard on a piece of a paper. Okay, so we obviously are going to have to shrink it. Okay, so this paper that we have is 20 centimeters by 15 centimeters. Okay, I'm obviously going to match the long side with the long side, the shorter side with the shorter side. Okay, I don't like meters and centimeters together, so I think I would like to change this to centimeters. Does anybody know how to quickly do that without a cross multiply? What do you times it by? How many centimeters were in that meter? 100. So 450 centimeters. 350 centimeters. Okay, let's take these numbers and divide them. What would I have to divide by? Okay, I'd have to divide by that. I'd have to divide by what to get there? What? I divided 450 by 20. Yeah. So I divided those numbers to say if I did 450 and divided it by 20, it's the same as doing the other way around, right? Because an 8 divided by 2 is 4, but you could also have done that the other way. 8 divided by 4 is 2. Okay, when you're doing this, think about this happening. If you're shrinking by 22.5, okay, this would be exactly 20. Okay, you don't really want on your diagram, you don't want to fill exactly 20, right? Because you probably want something to fit on your paper. So we would like to shrink it a little bit more so it fits inside our paper. So are you okay if I'm going to do reduce by 25? Would that make sense? That I'm shrinking it enough to fit on that paper? Because I have to pick something bigger. I could pick 24, but I like 25 because it's just a nice number and it's close enough to that. Okay, so when we talk about a diagram model here, a ratio, 1 to 25 or 25 to 1. Our diagram, it has to go diagram to real life. So where would you put the 1 and where would you put the 25? Every 1 on the diagram is actually 25 in real life. Okay, so how would that even fit on my paper? So this is my paper. Okay, and I would like to do this. Okay, so 1 on the diagram is 25 in real life. So what on the diagram would be 450? The side that's 450, what would its length be on my actual paper then? So divide it by 25 makes 18. So if I'm drawing this on my paper, right, that's nice, 18 by 1 to 25, diagram to real. How much diagram length will represent 350 then? 14. Okay, can you see why we picked 25 now? Because it's nicely fitting on our paper. It doesn't fit exactly, but that's not what you usually do on drawing diagrams. You don't want to fit it exactly on your paper. You want to make sure you have a little bit of space on your paper to draw it on there. Does that make sense? So that's why when I picked 25, I picked something just a little bit bigger to make sure I've reduced it enough to fit onto the paper. Okay, that's it.